Assalamualaikum and hi to everyone. Thank you for watching this video. You can subscribe, like and share. So in this video, we will discuss about the data encoding. We have data and we have the signal. So we need to do converting between the data into the signal. Basically, we only have two type of data and signal, digital and analog. So at the first part, we will discuss about the digital, and the second part, we will discuss about the analog. Okay, if we talk about digital, we have digital to digital encoding, and we also have digital to analog encoding. Digital to digital means we have digital data, we want to convert into digital signal. Digital to analog encoding means we have digital data and we want to convert into analog signal. Okay. The first part we go for digital to digital. Okay, the conversion involves three techniques for digital to digital. We have line coding, block coding, and scrambling. But under this topic, we only discuss about the line coding and the block coding. Okay, using the line coding process, line coding technique, we need to convert a digital data into digital signal. So basically, at the receiver side, we have a decoder, and at the sender side, we have the encoder. So encoder, process of encoder is convert the digital data into digital signal. At the decoder side, the decoder receive the digital signal and convert into digital data, and then the receiver able to read the digital data. So in digital to digital, you should know about the data element and signal element. So data element is referred to the R value. So data element and signal element are related to the R value. So you can refer to this figure. Okay, in this figure we have four figures. The first one, we have one data element per one signal element. So that means one signal bring one data element. Okay, one signal bring one data element. So the value of R here is equal to 1. 1 over 1 equal to 1. Okay, look at the figure B. One data element is carried by two signal element. So that means the R element, the R is equal to 1 over 2. 1 is referred to the data element and 2 is referred to the signal element. The next figure C, we have two data element carried by one signal element. So R equal to 2. And the fourth figure, we have four data element carried by three signal element. So R equal to 4 over 3. So if you are given data element and signal element, you should identify what is the value of R, because R is needed when we want to calculate the baud rate later on. Example number 1. A signal is carrying data in which one data element is encoded as one signal element. So that means we have one data element and we also have one signal element. Based on that fact, okay, we know that R is equal to 1. If the bit rate is 100 kilobit per second, what is the average value of the baud rate? So we need to calculate the baud rate or the signal rate. And then C is given between 0 and 1. So between 0 and 1 is 0.5 or 1 over 2. So we assume that the average value of C is 1 over 2 because the value is between 0 and 1. So the baud rate is calculated by C times N. N is referred to the bit rate times 1 over R. So we need to identify the value of C. C is 1 over 2. N is referred to that data. We have 100 kilobit per second. So 100,000 bit per second here. Change into the second. Make sure in the second. And what is the average value of this part? And then 1 over R equal to 1. So 1 over 2 C times 100 bit per second. This one is the bit rate. Times 1 over R. 1 over 1. This one is R. Number 1 here is referred to the R value. So we will get the answer 50 kilobaud. That is the signal rate. Okay. Although the actual bandwidth of a digital signal is infinity, the effective bandwidth is finity. Okay, that part is the theoretical of the bandwidth when we deal with the digital signal. Okay. The next part, we discuss about this lack of synchronization. Lack of synchronization. Okay. Effect of lack of synchronization. The synchronization of time, especially time at the receiver and the sender, should be in the same time. Otherwise, it will affect your transmission of data. Okay, this figure show you about the effect of lag in the synchronization between the sender and the receiver. The first one at the sender, the second one we have the receiver. Okay, the receiver side. Okay, at the sender side, you can see this one. This is the time frame. So the time frame similar, but the signal arrive earlier compared to the sender side. Means the clock at the receiver have faster compared to the clock at the sender side. So let's say at the sender side already sent 1 bit. At the receiver it already received 2 bit. So that is the effect of the synchronization between the sender and the receiver part. Okay, look at this example. This example is about the synchronization, the lack of synchronization. Okay, in digital transmission, the receiver clock is 0.1%, 0.1% faster than the sender clock. Means that receiver have clock faster compared to the sender clock. So how many extra bit per second does the receiver receive if the data rate is 1 kilobit per second? So you are given a data rate. You need to identify the extra bit being received by the receiver because of the time, because of the clock. So look at the 1 kilobit per second first. So at 1 kilobit per second, 1000 bit sent, 1001 bit received. So at 1000, we have extra 1 bit per second. Next, we look at the 1 megabit per second. So at 1 megabit per second, the receiver will receive extra 1000 bit. That is the effect of the synchronization. The effect of the lack of synchronization between the sender and the receiver. Okay, the next part we talk and we discuss about the line coding. Okay, line coding scheme is the technique that we can use in order to do conversion. The first one, we have 5, total 5, unipolar, polar, bipolar, multi-level, and multi-transitions. But we only discuss about the unipolar and polar scheme. So basically, those schemes are under line coding technique. Okay. NRZ mean non-written 0. NRZ non-written 0, RZ written 0, and then we have the bypass Manchester. This one is not about the Manchester United, but this is scheme on the line coding technique. Okay, we have bypass Manchester and differential Manchester. So we look at the unipolar first. We have the NRZ scheme. So under this scheme, if the data is 1, so the signal rate is positive, and if 0, so it put 0. 1 positive, 1 positive at 1. 0 is 0. So the normalized power here we calculate as 1 over 2 volt square plus 1 over 2 0 square. So this is the normalized power for the non-return 0 scheme. Okay, the next one we have NRZ-L scheme. So under non-return 0 scheme L level, 0 positive, 1 negative. 0 positive, 1 negative. So let's say you have a bit stream of data 0 1 0 0 1 1 1 0. You should know how to draw this signal. So if the data is 0, you put at the positive side. If the data is 1, you put at the negative side. So under this scheme, R is equal to 1 and S refer to N over 2. The baud rate average. Okay. In non-return 0L, L refer to the level. The level of the voltage determines the value of the bits. Okay, positive means 0. Negative means 1. So level identify the value of the bits. Okay. Non-return 0 level have DC component problem. Okay, the next technique is under the polar bypass. Okay, Manchester scheme. So in the Manchester scheme, we have two pattern. The first one pattern for 0 is look like Z, and then we have pattern for 1. It look like another Z. Okay, different part. So this is the pattern for 0. This is the pattern for 1. So let's say you have a bit stream of 0 1 0 0 1 1. So you need to draw this signal element. So 0, you draw here one pattern for 0, and then this one is 1. Draw this one. Okay, means 0. So this pattern. 0 again. So this again. 1 this pattern, 1 this pattern. So basically under this scheme, if you are given a bit stream of data, you should know how to draw the signal. And then under the Manchester scheme, R refer to 0.5 and the signal rate equal to the bit rate. In Manchester encoding, the transition at the middle of the bit is used for the synchronization. If we use the Manchester encoding scheme, okay, the middle bits is used for the synchronization. So both parties know that how to synchronize the process of transmission. And the minimum bandwidth of the Manchester is 2 times of the NRZ, non-return to 0 bandwidth. Means that Manchester has double time of the bandwidth for the NRZ. If we want to use the Manchester, we must have more bandwidth compare if we want to use the non-return 0 scheme. And then this one is the summary of the line coding scheme. Okay, for unipolar we have NRZ, and then we have NRZ-L for level, NRZ-I, and then we have the bipolar AMI. We have multi-label 2B 1Q 8-bit 6T. Okay, this part is about the bits. numbers of bits. And then we have the multi-line MLT transition. But in this topic, we only focus on the unipolar and unipolar for the NRZ and the Manchester. So basically, you should know how to do NRZ and the Manchester. How to draw the signal if a bit stream is given to you. So that's all for this video. We will continue on the next part on the digital to digital analog to digital conversion. Okay, in this video we'll already discuss about digital to digital using the line coding technique, and then we have two line coding technique, which are the NRZ and Manchester. Basically, we have a lot of scheme, but we only discuss about the NRZ and Manchester. Okay, the next part we will discuss about the analog to digital conversion. So that's all for this video. Thank you and Assalamualaikum.